Hello, welcome to PhyzQuest. This video is about the solution for JEST 2019 Part A, question number 8. So the question says, consider a diatomic molecule with an infinite number of equally spaced non-degenerate energy levels. The spacing between any two adjacent level is E and the ground state energy is 0. So what is the single particle partition function Z? So 4 options are given and we need to choose the correct option. So this question is based on the unit thermodynamics and statistical mechanics, and the concept involved here is partition function. So now you know that in statistical mechanics a collection of large number of system is called ensemble. Now there are 3 types of ensemble: microcanonical, canonical and grand canonical. Now what will happen is, depending on the ensembles are chosen depending on whether the system is isolated or in contact with the surrounding. Now the ensemble have a large number of particles with all possible energy states. Now certain fraction of members of the ensemble have certain characteristic. So how to distribute them? There comes the partition function. So the partition function is, the purpose of the partition function is it determines how the members of the ensemble distribute themselves over the available energy states. So distribute themselves means they partition themselves, basically. That's why the term partition function. Now according to the question, here we're talking about, in this definition the term ensemble is used. Now in this system, the question here, the system here is a diatomic molecule. Now it is mentioned that the diatomic molecule having infinite number of equally spaced non-degenerate energy levels. So we need to find out the partition function of this system, that is the diatomic molecule. So here basically we need to find out the molecular partition function. Now when we talk about the molecular partition function, when you consider a molecule, it has contribution, the energy of the molecule comes from different modes of motion. See, the thing is, partition function, to calculate the partition function we need to know the energy. Now in case of a molecule, there are different sources of energy depending on the different type of motion, or basically different modes of motion. So there are different types of motion, modes of motion, that is translational, rotational, vibrational and electronic. So these are 4 modes of motion. Now each of them will contribute to the molecular partition function. So molecular partition function will be a combination of translational partition function, rotational partition function, vibrational partition function and electronic partition function. Now the thing is, just remember that, just look at it here. It is mentioned in this that they have infinite number of equally spaced non-degenerate energy levels. So the term focus on non-degenerate. When we talk about non-degenerate energy levels, in case of a diatomic molecule, the vibrational energy levels are always non-degenerate. So we have to consider only the vibrational energy level, that is the contribution towards the partition function will be from the vibrational partition function only. So we have to focus on the vibrational part. So now we have sorted out of 4, only 1 we have to consider. Next step is we have to look for the formula. Now every type of partition function has a general formula, but in case of different modes of motion the formula does change. So here we have come to a conclusion that we have to only consider the vibrational part of the diatomic molecule. So now the molecular partition function can be written as Z is equal to summation over Gi e to the power minus beta Ei. So here Gi is your degeneracy of the energy level and Ei is the spacing between the energy level. This is a general formula. So these terms represent this only. Now in this question it is mentioned that the energy levels are non-degenerate. So here Gi is equal to 1. Okay, this is non-degenerate actually. Okay, so Gi is equal to 1. Now it is mentioned that the ground state energy is 0 and the spacing between any two adjacent level is E. That means the value of energy will be Ei is equal to 0, E, 2E, 3E and so on. So these will be the energy states. So now we have to Gi we have got, that is, since it is non-degenerate, Gi is equal to 1 and Ei values are 0, E, 2E, 3 and so on. So we have to expand this term and we have to put these values and write the expanded term. So when we write it, Z is equal to 1 plus e to the power minus beta E plus e to the power minus 2 beta E plus e to the power minus 3 beta E and so on. Now here this is an expression, it's a continuous expression. We need a specific term. So we have to use certain mathematical property to evaluate this continuous expression. So now there is a mathematical property, that is 1 plus x square plus x cube and so on is equal to 1 divided by 1 minus x. So this continuous term can be represented in this single term. So we will use this identity in this term. Now here it's 1 plus e to the power minus beta E plus e to the power minus 2 beta E and so on. So here if you compare both the things, here x will be equal to, in this expression, x is equal to e to the power minus beta E. So this expression we can write Z is equal to 1 divided by 1 minus e to the power minus beta E. So this is the answer we have got. And we can write the expression of beta also, which is 1 by kbt, that is the 1 divided by kbt. Kb is the Boltzmann constant and T is the temperature. So ultimately the final expression is Z is equal to 1 divided by 1 minus e to the power minus e divided by kbt. So now we have to check the options. So now check the options here. Option A is Z equal to 1 divided by 1 minus e divided by kbt. Option B is Z is equal to 1 divided by 1 minus e to the power e by kbt. C is Z equal to 1 divided by 1 minus e to the power 2e by kbt. And D is Z equal to 1 plus e by kbt divided by 1 minus e by kbt. Now the answer we have got is 1 divided by 1 minus e to the power minus e by kbt. So none of the options is matching with this. Our answer is matching with none of the options. But the correct answer is Z is equal to 1 divided by 1 minus e to the power minus e by kbt. Thank you.